So it sounds like you would like to solve this equation. You're wondering about the zero factor property, why we take out a common factor, and I'm assuming generally how to solve for x. So first thing, we need to get it into quadratic form, which is ax squared plus bx plus c equals 0. We need to get it in this form in order to solve for x. This is the method that we use. So to do that, we need to bring the 42 to the left-hand side of the equation. So I'm going to subtract it from both sides. And so when I subtract it from both sides, the 42 appears on the other side as minus 42. So now I have ax squared plus bx plus c equals 0. 0 is my y now. And when I'm solving a quadratic equation, I'm trying to find those x's that where the y is 0. So what I'm trying to find is the x-intercepts, those x's on the x-axis. This is the x-axis. I want those x's where the y is 0. The y is 0 on the x-axis. So I'm trying to find the x-intercepts. So I'm trying to find those x's which make the equation equal to 0. So what can I plug in for x to make this 0? Now, we don't have to factor out a common factor here to solve it, but it's much easier. It's a good rule to follow because sometimes you cannot factor if you don't take out a common factor. And it makes it, in any case, much easier if you take out a common factor. And you can see here that between 42 and 42, 2 is a factor of all those numbers. So 2 is a common factor. So if we take it out, 4 divided by 2 is 2x squared. Minus 2 divided by 2 is minus 1x. And 42 divided by 2 is minus 42 divided by 2 is minus 21. We set that equal to 0. Now we only need to factor this part. So I'm going to use the FOIL method, guess and check. I guess that 2x times x is going to give me the first term, 2x squared. And then I guess, and this may take you more than one guess, or you can use the factoring by grouping method, the product or the product sum factoring method. It's otherwise called the product sum factoring method, PSF method. But I'm using the FOIL or guess and check method. I guess these first terms, and then I guess these last terms here. The last times the last should give me the last term here, but then I check whether the outer product plus the inner product gives me this middle term. 2x times 3 is 6x. This is minus 7x. 6x minus 7x is indeed minus 1x. So this is the correct factorization. So now recall, we're still trying to find those x's that make the y over here 0. Well, if this factor is 0, then 0 times the other two factors will give us 0. Likewise, if this factor is 0, then 0 times these other two factors will give us 0. So what we want to find is what x will make each of these factors 0. Because that x that makes each of these factors 0 will make the entire equation equal to 0. So we solve for x in both cases. Bring the 7 to the other side, or add 7 to both sides. We get 2x is equal to 7. Divide both sides by 2, and we get x is equal to 7/2. That's one solution. Over here, take the x to the other side, or take the 3 to the other side, or subtract 3 from both sides. We get x equals -3. So that's the second solution. So our solution set is 7/2, comma, -3. Now, to understand why we have two solutions for x, here is a quick sketch. A quadratic equation of the form ax squared plus bx plus c equals 0 is in the shape of a parabola when you graph it. Here's the y-axis, here's the x-axis. Recall, we wanted to find those x's that make our y 0. Well, those are the x-intercepts. That's where the graph would cross the x-axis. And a quadratic equation being in the form of a parabola, it's like an upside-down St. Louis arc, can at most cross the x-axis 2 times. So here's one solution, and here's the other solution. Okay. Now in some instances, the parabola will only cross it once. We'll touch down at one point, and there we have repeated solutions. So where you have the 2 brackets, the x value that makes the equation 0 for each bracket might be the same. And then the third case is the parabola might not cross anywhere on the x-axis. That has no real solutions. Okay, so when we're solving for quadratic, the reason the 0 factor property works, where we set the equation equal to 0 and find those x's that make the equation 0, that is finding those x's that make the y 0. The equation is y. So we're finding, right here, y is 0. So we're finding the x-intercepts, those x's that make the equation equal to 0.